In this video, we'll be taking a look at how to solve inverse variation problems. So inverse variation is where one variable goes up as the other one goes down. The example being, the faster you drive, the less time it takes to reach your destination. So if v is your average velocity and time is the total time taken, then what we are going to say is t is inversely proportional to v. And there's this symbol that indicates proportionality. So notice that v now is flipped. It's an inverse proportion, so 1 over v now applies instead of v being on the top. And like the video before, we're introducing what's called the constant of proportionality, k. So t is equal to some constant of proportionality, k, but v is in the denominator. So let's solve this first example using this method and see how it's done. Okay, a 21-inch pulley rotating at 65 RPM turns a smaller pulley at 210 RPM. So the question's asking, what's the diameter of the smaller pulley? Well, this is an inverse relationship because as you have a larger diameter, you're going to have lower speed. In other words, speed is equal to k over diameter. So I want to solve for that k value, that constant of proportionality. So we have some information about the 21-inch pulley. At 65 RPM, you have the 21-inch diameter. So the goal is to get k by itself. It's attached to 21 by division. So if we multiply both sides by 21, then I'll be able to remove that 21. So in other words, k is equal to 21 times 65, which is 1365. So my general equation then is that speed is equal to my k value, which is 1365, divided by whatever diameter I have. Now, before I even finish solving this question, I want to think about what kind of answer I'm going to have. I had a 21-inch pulley, and it was rotating at a certain speed, and it's pulling, and it's turning this smaller pulley, which has a faster speed. So its diameter has to be smaller. So now let's put some numbers in. We're going to put in our 210 for our speed, and we want to solve for the smaller pulley's diameter. Well, we want to make sure that we do this algebraically correctly. So we're going to multiply both sides by diameter. And diameter is now on the left side. Want to get the diameter by itself. So in other words, that 210 is going to get divided out, so it's 1365 divided by 210. And when I do that in my calculator, I get a diameter of 6.5 inches, which makes sense because that pulley was rotating at a higher speed. Okay, so pause the video, take a moment, try question 2, and then see how you do. And I let my time be indicated by t and my speed, 90 kilometers per hour, be indicated by v. So I'm going to use that same equation at the top of this page, t equals k over v. So I hope you were able to get a result of t equals 2.8125 hours when the speed went down to 80 kilometers per hour. And this again, this answer makes sense. It's going to take me longer when the speed goes down.